This is the 30th point of friction. It is an opposing or retarding force which comes into play when a body tends to slide over the surface of another body. Another is the sliding friction. It is an opposing or retarding force which comes into play when a body tends to slide over the surface of another body. The next one is the limiting friction. It is the maximum value of static friction which is in play when a body tends to slide over the surface of another body. Dynamic or the kinetic friction. It is the opposing or retarding force which come into play when the body actually slides over the surface of another body. Next point is about the laws of friction. Among that, the first is the direction of the force of friction is opposite to the direction of the motion. The force of friction depends on the nature and the state of polish of two surfaces in contact. If they are polished, in that case the friction is less within the point of contact and the surface of the object. If there is roughness, then friction offered will be more. Now, continuing with the laws of friction, in that series, the third point is the force of friction acts tangentially to the interface between the two surfaces. The next is the limiting friction is directly proportional to the normal reaction between the two surfaces in contact, and the limiting friction is independent of the area and whatever may be the shape of the two surfaces in contact, provided the normal reaction has not changed. The 35th point is about the coefficient of friction. It is the ratio of limiting friction to the normal reaction denoted by mu. Angle of friction. Angle of friction is between the resultant of the normal reaction and the limiting friction and with the normal reaction. Here R is the normal reaction and F is the limiting force. So from figure we have tan theta is equal to limiting friction upon normal reaction, and this thing is equal to mu according to this relation. Now it is concluded that tan of the angle of friction is equal to the coefficient of the static friction. The next is the angle of repose or the sliding angle. It is the angle which the inclined plane makes with the horizontal when the body is placed on it just starts slipping. It is denoted by phi. So you can just see this is the body that is just going to start the slipping, and the weight mg is acting in the vertical downward direction. R is the normal reaction, and this angle phi is the angle of repose or sliding angle according to the definition, and the body is slipping in this direction and frictional force is in the upward direction. So this is resolved in two of the direction, this weight mg cos phi and mg sin phi. Now it is clear from the figure that tangent phi is equal to the limiting friction on the sliding plane by the normal reaction R, and that thing is equal to mu, the static friction. Here again we get the tangent of the angle of repose is equal to the coefficient of static friction. The next is the acceleration of a body sliding down on inclined plane. This inclined plane is there, and with what acceleration it is moving? This is given by A equal to G sin alpha minus mu cos alpha, where alpha is the angle which the inclined plane makes with the horizontal. The next point is about when a body moves through a distance s over the frictional horizontal plane, the work done is given by W is the work done. This is equal to mu, that is the coefficient of static friction, mg into the distance. Otherwise the formula of work done is force into distance. So this part is denoting the force here and it is multiplied by the distance. The next is about the work done in moving a body up an inclined plane through a distance s is given by mg into distance into sine theta plus mu cos theta. The next is about the rolling friction. It is opposing force which comes into plane when a body actually rolls or tends to roll over the surface of another body. The next is about the centripetal force. Centripetal force required by a particle of mass m moving with velocity v of a circle of radius r is given by F equal to mv square by r, or F is equal to mr omega square. V is equal to r omega. These relations, angular velocity, angular acceleration, we have already discussed in the unit number 2 kinematics. You can see the link below and can find out those terms that are related to the circular motion. Here I am taking the centripetal force. So the next is, this force is also equal to 4 pi square mr by t square, where t is the time period, or F can also be written as F is equal to 4 pi square mr nu square, where nu is the frequency. We have nu is equal to 1 upon t, this relation, so that thing is replaced here, and 1 upon t square is mentioned as nu square. Omega is the angular velocity that we have used in this relations, t is the time period, and nu is the frequency. The centripetal or the radial acceleration is given by v square by r. Now the 44th point, when a particle moves with uniform circular motion, it has only one acceleration called centripetal acceleration. But when a body moves with non-uniform motion, circular one, it has two accelerations, centripetal acceleration and the tangential acceleration. This acceleration, that is centripetal, it is directed towards the center of the circle. On the other hand, when the circular motion is non-uniform, the centripetal acceleration, that is directed towards the center of the circle, and tangential acceleration is directed along the tangent. The next point is, when while taking a turn, the cyclist should make an angle theta with the vertical such that tan theta is equal to v square by rg. V is the velocity, r is the radius of that arc that it is being making, and g is the acceleration due to gravity. When the outer edge of a circular track is raised above the inner edge, two edges are there, one is the inner side and one of them is the outer side. The outer side one is bit raised. The track is said to be banked. This type of track is called a banked track, and the angle of banking is given by the same formula that we have seen there, tan theta equal to v square upon rg. Next point is about the minimum velocity of projection at the lowest point of the vertical circle, so that particle may loop the loop, is given by under root 5 gr. G is the acceleration due to gravity and r is the radius of the circle. The next is the maximum speed with which a car can take a turn on a circular level road is given by mu s into r into g, where mu s is the coefficient of static friction, r is the radius of circular turn, and g is the acceleration due to gravity. The next point is about the maximum speed with which a car can take a frictionless banked circular track is given by under root gr tan theta. Here theta is the angle of banking. Next point is the maximum speed with which car can take a turn on a rough banked circular track is given by under root tan theta plus mu divided by 1 minus mu tan theta rg, where mu is the coefficient of the friction. Let us see the questions of friction. A football player is moving southward and suddenly turns eastward with the same speed to avoid an opponent. The force that acts on a player while turning is along northward, along northeast, along southwest, or along the eastward. This question has come in NCERT new page 60, and it has been in the NEET 2023. So here we see this question is in which the football player is moving in the southward direction. So these are the directions. This is the north, south, this is the east, and this one is the west. So the player is in southward direction. At this moment, the force will be in the opposite direction because of friction, that will be towards north. So, since the force of friction is in opposite direction. So when the player is in south direction, the force is in north direction. After that, there is a sudden turn towards the east side. Here, which thing comes in play? This is the, according to the force of motion. If there is sudden change in the direction, means velocity, so change in momentum comes in the role. So according to the force of motion, the force will be in the direction of change in momentum. Since it has moved towards east, so change in momentum is also in the east direction. Since players change in momentum is in east direction, so direction of force is east. So what we conclude? For the first instance, the force is in the north direction, and when the sudden turn is being there towards east, the change in momentum, and in that direction the force will be, and that will be in the east direction. So the force that is acting on the player while turning is from north to east, so the option is along northeast direction, and hence the answer for the first part is B, along northeast. Question number 2, calculate the maximum acceleration of moving car so that a body lying on the floor of car remains stationary. The coefficient of static friction between the body and the floor is 0.15. Take acceleration due to gravity 10 meter per second square, and these are the four options given. This is on the page number 61 NCERT new, and this question has come in NEET 2023. Now let us see the solution of this numerical. Take the things that are being given. We have to calculate the maximum acceleration and the coefficient of static friction. Mu s is given to us 0.15. Acceleration due to gravity to be taken 10 meter per second square, and the maximum acceleration is to be calculated in the question. So we'll be applying the formula for the same, and the question is based on the direct formula if you remember the concepts. So F is equal to mu smg. Also, the force is equal to mass into acceleration. These are the two formulas that will help us to do this numerical to find out the acceleration. So ma is equal to mu s mg, and a will be given by mu s is 0.15 and acceleration due to gravity is 10. So the value will come out 1.5 meter per second square. This will be the value of the acceleration, and we'll look at this. The option B goes with the answer, and the answer for the second is B part. Now let us see the third question. Calculate the acceleration of the block and the trolley system shown in the figure. This is the figure given in the question. The coefficient of kinetic friction between the trolley and the surface is 0.05. G is to be taken 10 meter per second square. Mass of the string is negligible and no other friction exists. These are the options given, and this question has come in the NEET October 2020. So now look at the solution of this question. So in this diagram, we see with the help of this pulley and the block that is balancing the trolley, and this is undergoing the kinetic movement because the coefficient of kinetic friction have been given, and we have to calculate the acceleration. So the acceleration will be in this direction, and the weight, the mass of this is 10 kg. So to balance this, the tension in the string is acting in this direction, and here the tension in the string is in upward direction as the weight mg. Mg is 2 into g. This is acting in the downward direction. So to solve this, first see the equation of motion of trolley. The equation of motion of trolley is given by the net force will be T minus the force of friction that will be in the opposite direction, it will get subtracted, and this thing is equal to, since there is an acceleration, so mass into acceleration. This is the equation of motion. So we have T minus mu is given to us 0.05 and R will be mg, mass is 10 kg, and g will be taken 10 as per the question. Again the mass is 10 and acceleration is a. So this value comes out T minus 5 10a. Mark it as equation number 1. Now equation of motion for the block is given by, here the movement is in downward direction, so downward weight minus tension in the string is equal to the net force, that is mass into acceleration, that is 2a. Now if we are going to add the equation number 1 with equation number 2, we can eliminate this tension and from there we can get the acceleration. So in equation 2, again we will put the value of g, that is 10 minus t equal to 2a. So 20 minus t is equal to 2a. Adding equation, mark it as equation number 3. Adding equation 1 and equation number 3, we have t minus 5 plus 20 minus t is equal to 10a plus 2a. This cancels, so 15 is equal to 12a, or acceleration is equal to 15 by 12, that is 1.25 meter per second square. So acceleration comes out 1.25 meter per second square, and from here option number A goes the correct. So answer for the third is option A. Now the question number 4 is, which one of the following statement is incorrect? Frictional force opposes the relative motion. Limiting value of static friction is directly proportional to normal reaction. Rolling friction is smaller than sliding friction, or the coefficients of sliding friction has dimensions of length. This question is NCERT new. The page number is 61 and it has come in the NEET 2019. So let us see the options one by one. Now if we see frictional force opposes the relative motion, if we are talking about A option, so this is always true. Frictional force comes into play when there is relative motion between two bodies, or motion between two bodies in contact. So this statement is correct. There is no problem with this. This is not an incorrect statement. Now if we look at the option number B, Now, if we look at the option number B, limiting value of static friction is directly proportional to the normal reaction. So, we know the relation F is equal to mu R, where F is the value of the static friction, mu is the coefficient of static friction, and R is the reaction. So R is equal to F upon mu. So there is a direct proportionality between the limiting value of static friction and the normal reaction. So B is also a correct statement. Now look at the option number C. Rolling friction is smaller than the sliding friction. This is also correct statement. In the rolling friction, there is less surface in contact. There is less surface in contact between the bodies that will be in contact, or we can say there is only one point of contact. Since there is less point of contact, so frictional force is less. So rolling friction is always smaller than the sliding friction. This statement is also correct. Then the option number D, coefficient of sliding friction has dimensions of length. So if we look at this formula, here we can have the coefficient of sliding friction, that is mu is equal to F upon R, where F is the force and R the normal reaction, again that is the force. Since both are having the dimensions of force, this is again having the dimension of force, so mu can never have the dimensions of length. So our statement D, this is incorrect. Coefficient of sliding friction has dimensions of length, rather it don't have direction. It don't have, sorry, dimensions. Coefficient of sliding friction is dimensionless. It is dimensionless, and option D is the correct option. This of the statement, coefficient of sliding friction has dimensions of length, is incorrect, and the answer for the fourth is option number D. Now we are taking the topic of dynamics of circular motion. In that, the first question is, a wheel of a bullock cart is rolling on a level road as shown in the figure below. This is the figure that is for this question. If its linear speed is v in the direction shown, so v direction is being shown with the arrow, which one of the following option is correct? P and Q are any highest and lowest points on the wheel. This point is P and this point is Q, highest and the lowest point. And these are the options given. This question is on the page number 121 of NCERT, and this question has come in NEET 2024. So to solve this question, we have to see the types of the motions involved. So this is a wheel that is moving in this direction with linear velocity v. If we look at every point of these circle, it is moving in the forward direction. Along with that, there is a circular motion within it. So at point P, the direction of that is r omega, where r is the radius of this wheel and omega is the angular velocity. If we consider this point, at every point that will be lying, the direction will be lying at the tangent. So at this point, r omega will be in this direction. R omega, the direction will be this. And this will be going in the opposite direction. this will be the upward direction. So this is how at every point the direction of this is going to remain changing. So if we have to confine to the point P and Q as asked in the question, if we look at these 2 points, so r omega and this velocity, linear velocity, are in the same direction for P point, and for Q point r omega is in opposite direction to the linear velocity for Q. So these are the vector quantities, and you know that when the vector quantities they are added up in the same direction, the resultant is maximum, and in opposite direction it is minimum, and at other every point the value of that is being added as per the law of vector addition. But highest will be for that in which both of them are in the same direction, क्योंकि P और Q जो दो पॉइंट्स हैं इनमें हमारी एंगुलर वेलोसिटी और जो लीनियर वेलोसिटी है वो दोनों सेम डायरेक्शन में जा रही है, तो हम उनको सिंपली ऐड अप कर सकते हैं। सेम डायरेक्शन में जब भी हमारे पास वेक्टर्स को ऐड किया जाता है तो रिजल्टेंट मैक्सिमम होता है, और ऑपोजिट डायरेक्शन में हमारा रिजल्टेंट मिनिमम होता है, और किसी और पॉइंट पर अगर हम लोग वो निकालते हैं तो वो वैल्यू जो है दैट विल बी डिपेंडिंग अपॉन द एंगल, बट मैक्सिमम जो है वो पी पॉइंट पे होगा, उससे कम ही आएंगी वो वैल्यूज जो हम ऐड करके आएंगे, क्योंकि वो किसी ना किसी एंगल इंक्लाइंड पर आएंगी। तो इसमें हमारे पास कंक्लूजन ये आ रहा है कि पॉइंट पी और पॉइंट क्यू जो है अगर हम उनको कंसीडर करते हैं तो वहां पर हमारी वेलोसिटीज पी पर हायर वेलोसिटी रहेगी इन कंपैरिजन टू क्यू। Now option A is point P moves slower than point Q. No. Point P moves faster than point Q. This option is correct. Let us see other options also. Both the point P and Q moves with the equal speed. No, not at all, because they are having the angular velocity in different direction. Point P has zero speed. Again, this is incorrect. So option point P moves faster than the point Q is the correct option. And the answer for the first is option B. This is the question number 2. Two particles A and B are moving in uniform circular motion in concentric circles of radii RA and RB with speed VA and VB respectively. Their time period of rotation is same. The ratio of angular speed of A to that of B will be, and the options are there. This is on the page number 63 of new NCRT, and this question has come in NEET National 2019. So let us see the solution of this question. We are talking about the time period of rotation and the ratio of the angular speed. So in case of a circular motion, the angular speed denoted by omega, this value is equal to angle subscribed in circle over time. This is the formula. If the complete rotation is being taken with the total time period of one cycle, then angle subscribed in a circular motion, say from starting from point A and completed the full circle and coming back to the position A, then the time period capital T is being taken and the angle subscribed will be the full angle, that is 2 pi by T. So this is the formula for the angular speed with respect to the time period. Now for these are the concentric circle. For the circle with radius RA, the angular velocity is given by 2 pi by TA, and for circle with radius RB, the angular velocity is given by 2 pi by TB. Mark it as equation number 1 and equation number 2. we have to take the ratio of the angular speed. So omega A to omega B, this ratio will be 2 pi by Ta into Tb by 2 pi. So this cancels. Now, one more thing is being given here. The time period of rotation is same. Since time period of rotation is same, it means Ta is equal to Tb, and they will be cancelled out because they are same. So the value comes out 1:1. So if we look at the options, option number C is correct. The ratio of the angular speed of A to that of B is 1:1. So answer for the second is option number C. Now is the third question. A 500 kg car takes a round turn of radius 50 meter with a velocity of 36 kilometer per hour. The centripetal force is, and the options are being given. This question has come in All India PMT 1999. If we see, to solve this numerical, write down the things that have been given. Mass is given 500 kg. Radius is 50 meter, and the velocity is being given 36 kilometer per hour. If we look at the mass and radius, they are in the SI unit. Options is also in SI unit. So let us convert it in SI. So 36 to convert in meter per second, multiply by factor of 5 by 18, and the value comes out 10 meter per second. So this is a direct formula based question. The centripetal force we know. If you remember the formulas that we have discussed, centripetal force is given by, here m, r and v is there. So mv square by r. Now we can put the values. 500 into 10 square, and radius is the 50, and when we are going to solve it, it comes out 1000 Newton. So if we look at the options, it goes with option number C, and the answer for the third is option C. This is the question number 4. A ball of mass 0.25 kg attached to the end of a string of length 1.96 meter is moving in horizontal circle. The string will break if tension is more than 25 Newton. What is the maximum speed with which the ball can be moved? And these 4 options have been given. This is on page number 64 of NCERT New, and this question has come in All India PMT 1998. So before starting this question, see one very important thing. Whenever there is a string attached to a body and that is undergoing the horizontal movement in the circle, in this case a very important concept is there. For circular motion in horizontal direction, tension in the string is equal to centripetal force. Based on this concept, many times the question has come in many ways, but the concept is going to remain the same. So this is what we will be following to solve this question. The tension that is maximum, since this tension is, if goes beyond this value, then that will break. So it can have maximum this much tension, 25 Newton. And maximum speed for which we are denoting it by V maximum by R. Now, what we are supposed to find out, the speed. So, V maximum is equal to tension maximum R over M. Now, the value of T is 25. The value of R is 1.96. This length is going to be the radius. See, this is the body attached to this, and this is going to move in a circular motion. So this length will become the radius. So length of the string is 1.96, that will be the radius, and the mass is 0.25. So this is 25 into 196, 25 cancels, under root 196, this will come out 14. So V maximum is 14 meter per second. And if we see the option number A goes with it, and the answer for the fourth is option A.